Hi everyone, in this video we're going to be talking about naming haloalkanes as a particular family within our set of hydrocarbons that we come across. Then we're going to learn some of the specific rules that we need to know to help us to come up with unique names for haloalkanes. So let's start with our overview. We're going to talk about what are haloalkanes, give us a little bit of background as to what is particular about those compounds. We're going to look at how, in recognizing that we have halogen atoms in our structure, we can look at how we're going to name those halogen atoms. We're going to review our naming rules that we've come across before, and then we're going to go through some worked examples. All right, let's get into it. Okay, so just a reminder that we have a range of different hydrocarbon families that we come across. So where we have related compounds that are we group together based on a common feature or a common characteristic, whether it's the bonding that they have, whether it's a particular kind of set of atoms that are connected within their structure that gives them that unique quality. Okay, so you can see the list of some of the common families we come across there on the left. We're going to particularly focus on haloalkanes, so that one kind of in the middle, because we've learned a little bit about how to name some of the other types of examples before. And if you like, you can go back and revisit that video to remind yourself about how to do that. But so we're going to focus on haloalkanes. So haloalkanes are those that have one or more hydrogen atoms. So an alkane with one or more hydrogen atoms that's been replaced by a halogen. So that's fluorine, chlorine, bromine, or iodine. One of those, the elements that exist in group 7 of the periodic table, the second last group on the right-hand side. So you can see some examples of some different haloalkane compounds shown here. Okay, so when we want to name halogens, when we want to identify which halogen atom is present, or which types of halogens are present in our compound, we need to use a particular prefix for that halogen. You can see the table here. When we have a fluorine, we use fluoro. Chlorine is chloro, and so on. That we use that to show that those atoms are present. Because lots of the time in haloalkanes that we're going to encounter, we will have more than one type of halogen. So we need to know how to name each one and also to put them in a correct sequence. That's logical. Because the idea is that if you've got more than one, the overall idea is that you would place them in alphabetical order in your name. That you would write bromo before chloro, before fluoro, before iodo, if you happen to have all 4 of those things in there. That only happens if you've got more than one type, but it's important to get that right, because this is one area that the concrete chemistry textbook gets wrong, because the naming system had changed at some point in the past, and so it's important that we can help clear up the confusion. If you do have more than one of a particular halogen, just like with any other functional group, we use di, tri, or tetra to help show how many that we've got of that particular atom. Okay, so let's have a look at the rules that we would follow. So here we're talking about a slight tweak to the rules that we're used to. As before, looking at the number of carbons in the longest unbranched chain, that gives us our stem, meth, eth, prop, bute, and so on. We then look at the bonding to identify the hydrocarbon family and give it its suffix. Now remember, we're talking here about haloalkanes, so our suffix will be -ane at the end, but it's the presence of that halogen prefix that's going to be what's different here. Okay, so we're going to identify any branching using the stem and the YL suffix, but if memory serves, in our syllabus you don't actually need to be able to name branched haloalkanes. You just need to be able to identify straight chain haloalkanes up to 8 carbons long. And so then we look at our numbers. So remember that we need the lowest overall set of numbers based on the functional groups that we have. And so what we see though here is that you can sometimes get some different names that are equivalent to each other. You go 3, 4, or 4, 3. And so what we do is we assign the lowest number to the halogen that is named first alphabetically. So bromo would get the lower number over chloro, or chloro would get the lower number over fluoro, and so on. You'll see in some of the worked examples that will help to clear that up a little bit. So this is the particular area that is different in concrete chemistry. Okay, so just really be mindful of that, to check that carefully, and you'll notice that there's been a few glitches in past paper questions along those lines. Okay, so we've got two worked examples to go through to finish up our video today. Okay, so looking at the compound that you see here. So first, as always, we identify how many carbons in our chain. We can see we've got 1, 2, 3, 4, 5, 6. So we have a stem of hex. Now remember, we're talking haloalkanes, so the suffix is always going to be an ane because it's just like an alkane with a halogen atom that's been swapped. And so what we see is that we've got a chlorine atom over here. And so that chlorine gives us the chloro prefix that we're going to need to put in our name. So we've got a hexane, we've got a chloro, so it will be chlorohexane. But what we need to do is we need to use our numbering to identify which carbon that chlorine is attached to. Now, as usual, we have two ways that we can number, from left to right or right to left. We need to try and decide which one is going to be appropriate in this situation. So left to right, we can see that we're going to get carbon number 4. But if we number right to left, we can see we get carbon number 3. So the green numbers are the ones that we're going to be using. So we can see chlorine is attached to carbon number 3, so that we'll have the 3 connected to it. And so then we would write our name as 3-chlorohexane, remembering that we use the hyphen between the number and the word. Okay, so let's look at a second slightly more complicated example. We can see here, same process as before. We can identify a chain of 5 carbons in length, so our stem is pent. Haloalkane, so our suffix is ane, so it's a pentane kind of backbone that we would see. But what we can identify is that we have both a bromine and a chlorine in this structure. So we're going to need some of our higher level rules that kind of kick in towards the end to help to decide how to write this name. So we're going to have a bromo and a chloro in our name, and we will put them in that alphabetical order. That we'll write the bromo bit before the chloro bit. So now we get to our naming process. We can do left to right in red or right to left in green. Now what we notice here is that in whichever way we number, we get a 2 and a 4. So we either get 2 for the bromine and 4 for the chlorine, or 2 for the chlorine, 4 for the bromine. So overall, our sets of locants are the same. So what we need to do is we need to decide or recognize that we need to give the lower number to the one written first alphabetically, which in this case is the bromine. So the green numbers help us to do that. So they're the ones we're going to stick with. So we've got bromine at number 2, chlorine at number 4. So we're going to say 2 bromo and a 4 chloro. And we're going to put our name as 2 bromo, 4 chloropentane. Notice that I've got all hyphens between numbers and words. In every situation here, we don't have any spaces. This just happens to spill down onto a second line. Okay, so really make sure that you're aware of that so that you can get the grammar right in this situation. So this is one of those examples where you need the slightly higher level rules to be able to identify which is which. But using those rules, you can follow and work through examples just like this. All right, thanks very much for watching. Bye for now.